Great. Welcome in, everyone. Hi, my name's John, staff software engineer with 10 plus years of experience. I'm the lead maintainer of Latterly.io, an open source educational platform that helps you land your first or next programming role. Today, we are going to deal with Palindrome linked list. And in front of us, we have an easy number 141 linked list cycle as a warm-up problem. This helps us get into the flow, into the mindset of dealing with linked lists. These are items 4 and 5 on the Leetcode Latterly kata. And you can see here I am back in my normal Leetcode account. And here's my solved problems. In a previous stream, someone was asking me about this. I'm going to take 2 minutes and go through how I was able to reset my password. It's a bit of an interesting story. I transferred my email address, john@afterecon.com. And feel free to email me here if you'd like. So the afterecon.com domain was previously a WordPress website on GoDaddy, and I moved the domain hosting to Vercel. And in that process, I lost my email forwarding, so I was unable to log into my Leetcode account because I couldn't reset my password. So here's how I solved that in 2 quick minutes. It was really easy. Did a Google search for Vercel domain forwarding, and I found this article with this solution at the bottom using forwardemail.net. So I checked it out and I highly recommend it. It was really easy. It took me about 10 minutes or less, and it's free. So if you run into this issue where you have a Vercel domain, Vercel does not natively support email operations, MX records. But you can sign up totally for free and use this service, so I recommend that. You can see afterecon.com, the website is not hosted on Vercel currently. So this is just the 404 that Vercel gives. I will be doing a WordPress migration into Vercel. So let me know if you're interested in me streaming that or if I should just do it by myself. And on that note, I'll mention a few times during today's stream, please vote by comment what sorts of content I should be doing upcoming. More Leetcode, open source web development. I can do web basics, job search techniques, all sorts of other stuff. We can do current events. We can bring in industry leaders and have a chat if that's interesting to you. Let me know. I'll come back to this page a couple times. And then a quick shout out that I just released Intro to Streaming in 13 concrete tips. Here's the video. This came out today. This would be an example of some of the content creation work that I could do if you're interested in that. I also tried to echo the same question as a poll on my YouTube channel. It limits me to 4 options. Again, here you can see I have like 11 options, but there is an other category, and definitely comment if you're interested in another kind of content that I didn't list as a potential option. So with that, let's dive into the Latterly Leetcode kata. This is my recommended approach to practicing Leetcode. And in a previous stream, I did like 1 through 4. And then today we're picking up on 4, and we'll go and get that palindrome linked list item number 5. So here we are. Diving in first to the, let me leave that tab open so I can easily access palindrome when we get there. So we're diving into this basic linked list cycle. Given the head of a linked list, let's determine if the linked list has a cycle in it. And the problem reads, there is a cycle in a linked list if some node can be reached again by continuously following the next pointer. Brandon, welcome in. Brandon says, what language are you going to do? I prefer to do Leetcode in Python these days. For early career individuals, Latterly teaches a portfolio-oriented development curriculum. So you'll learn HTML, CSS, and then JavaScript. You'll then progress to TypeScript. And only once your portfolio is established with 3 projects do I introduce Leetcode. And the reason for that is you can get a programming job without ever doing Leetcode. So Leetcode is table stakes in tier 1 and for FANG companies. But for tier 2 and tier 3 companies, very often you can land a job with just the portfolio. That means that you'll have the background in JavaScript and TypeScript when you approach Leetcode, and I think it's totally appropriate to start answering those Leetcode problems in JavaScript. That's totally fine. Later on, if you branch into Python, you will realize that Python offers simpler, more concise solutions to many Leetcode problems. And it's really advantageous to learn that second language because you can understand the abstract data structures very well. Once you have multiple languages, then you'll start thinking about the abstract data structures instead of the language-specific syntax. And that's really a good marker, I think, for mid to senior levels. Really, a mid-level developer to a senior developer is one who knows multiple languages. So by the time you're a senior, I'm going to recommend you learn Python for Leetcode. As a junior, feel free to stick with JavaScript. I wouldn't recommend TypeScript just because writing out the types is verbose and unnecessary. I, as a staff software engineer, am very comfortable using Python these days. So I'll stick with that. And you can see in the Leetcode IDE, we have Python 3 selected. Thanks for the question. Thanks for being here. And thanks for the likes. 9 likes already. Thank you so much. Keep those coming. Okay, so we'll continue with the problem. So the problem notes that internally POS is used to denote the index that tail's next pointer is connected to. I think the only reason to be mindful of this note is if you use a variable named POS, weird things might happen in your problem. So more or less, as long as we avoid POS, I think that's not going to be an important note for us. And then the problem says, please return true if there is a cycle, otherwise return false. And that is the same as indicated by the type hint on the hasCycle method, that we're just going to return a Boolean. Amanda, welcome in. What language? We'll be using Python today. Yeah, after I take care of these 2 problems, if you want, I can consider re-implementing in JavaScript. Drop a comment in the chat if you'd like to see that happen. Otherwise, I'll stick with Python. We'll go to a couple of these examples. We can see in example 1, we start at a head node, go down to 2, 0, -4, and then we come back to the 2. So that means there is a cycle. So we return true. In the linked list, as the pointer progresses, we'll get stuck in the circle. Example 2, we're stuck in a circle from the head node. None of these examples show a self loop, but I would assume that if there was just a 1 pointing to itself, that would also be a cycle. And then in example 3, there is no self loop. So it's just a pointer to a null, and that is returning false. There's no cycle. So we can think through a couple implementations here, and I don't see any constraint. Well, here we go. Can you solve it using O1 constant memory? So that'll be a nice goal right away. We could turn this linked list into a standard list or array, and then cache the elements in that array or a set, and then check if we have already visited that element and return true at that case. That would require O of n memory if I have all of these elements in a set or list. So I'll put as an option cast to set or list, then check if node is in the scene cache. This would be O of n space. And then another option, so we're sort of brainstorming options here. Can I use O of 1 space with just pointers? And the answer will be yes. So how can I detect a linked list only using pointers? We can use left initialized fast and slow pointers. And so they will proceed at different rates. And if they ever collide, that means that there's a loop. And so that'll make more sense as I implement it. What about time complexity or performance? Both will be O of n asymptotically. Technically, if I had this scene set or list, I would need to store n-1 elements, because whenever I got to the last element, I wouldn't need to store it because I would see that it's been visited, yes or no, and I would return there without the need to cache it. But asymptotically, n-1 is going to equal O of n. Amanda says, do you teach Python with your lives, or do you have any YouTube channel? I do. If you are on TikTok currently, you can go to my bio, and that will take you to this site, which has all my socials, including YouTube. The current stream will be persisted at YouTube. By the way, this social home website is also open source. Feel free to copy it. And so you can go to lives and see all my live streams. I mentioned earlier, I'll mention it one more time. Actually, I'll mention it a few more times throughout the stream, that you can vote by comment on the kind of content that you would like to see, Amanda. And so I typically don't teach Python, but I'm willing to go into it. I use this at my day job. I've been doing Python for years. And so you can let me know if you would like software engineering in Python, or maybe data analysis, data science, AI, ML, generative technology. So I'm a staff software engineer in applied generative AI. And so things with language models, we can get into that if you're interested. Just let me know. Thank you so much for being here. If that sounds interesting, I hope you'll follow the page and throw a like on the video. Brandon says, is fast 2 ahead and slow goes up 1 every time? Basically, yes. So fast does not need to be 2 ahead. We will initialize them both at 0. They'll be left initialized. But the fast one will move twice when the slow one moves only once. So it will end up being 2 ahead, just not at initialization time. Not trying to split hairs, just trying to answer your question. Good question. So let's go ahead and do that. So here I will say fast is head. So initializing at the left, initializing at 0 would be an index reference, but we actually don't want to use an index reference. We want to use an object reference. So fast is head, slow is head. And then I'll say if not fast, because you see in the type hint, head is optional. So they both might be null initially. So I'm going to handle that edge case. So if it's not there, then I will return false. There can't be a loop in this case because they are just null references. So there would be no loop. Amanda says, loved, I will watch your YouTube channel. Thank you so much for being here. Okay, so now we are effectively guaranteed that fast and slow have some reference. And so I will say while fast, we'll just do a high level structure here. I will, to do iterate. And then if we get through this loop, that means fast hit a null reference at some point, and so the loop did not continue. So this is a truthy evaluation. So if it ends up being null, it will exit the loop. And if we exited the loop, that means there won't be a loop. Does that make sense? So if we ever reach line 21, the head data structure is not a loop. So how do we iterate in here? While I have a reference to fast, I'm going to say fast is fast.next. And I'd like to do fast.next.next, but I can't do that because fast.next might be null. So here I'll say fast.next and fast.next.next. That's a short circuiting truthy evaluation. This might let me point to the next reference, and then slow equals slow.next. So you can see fast is moving twice each iteration and slow is only moving once. There's a problem here. If fast.next ends up being an object that doesn't have a second step, they could end up pointing to the same node. So I could handle that here, or I could adjust my while statement. So I'll say while fast and fast.next. So I guarantee that they both exist. Then I can go ahead and do this. And they might still both point at a null. So if they both point at, so I'll do one more check here. So if I have a fast, if I have a fast and it is referring to slow, then there has been a collision, then we'll return true. And I'm using the JavaScript Boolean names. So we need to capitalize all our bools. And there we go. This performance right here, I think there's a lot of noise. If I just run the same thing again. Oh, this looks slower. That's interesting. anyway, we got a solution. So let's go for the palindrome then. So here's a palindrome linked list. Let me get rid of all this. So I've solved these problems before. This is not like my first time. Oh, can you go over the logic to the ands? Sure. So the logic to this and will be that I want to avoid fast and slow both pointing to fast.next, because what I want to do is I want to say if fast equals slow, return true. But if I do, but if I do the short circuiting and, maybe I can just show you. This might pass my, yeah, it doesn't even pass these test cases. So maybe it would be make things clearer if I see exactly where this breaks. So in this case 3, I only have the head node of 1. And so fast and slow are both initialized to point to that first node. With me? So they both point to the first node, if not fast. Well, I do have a node, so we're not going in there. So we're coming over here. While fast, well, I do have fast. So fast is fast.next. So that would be none. And fast.next.next. That's not a thing. So fast.next is none. In Python, none is like a null. It's basically the same thing. It's Python's word for null, basically. So this is now pointing at null. Does that make sense? So now that the fast is pointing at null, and then slow will also point at null in this case. So if I say I'm looking for a collision, if there's a collision, I think there's a loop, but actually they're both pointing to null, and I get this inaccurate true return. So that's why I want to have a compound check. I want to make sure that I still have a pointer to a valid node and they're equal. So that's why I added that secondary check. Does that make sense? If they both point at null, this statement will be bypassed and the while loop will break and I'll end up here, which is the right location. Okay. What about the palindrome case? So let's give the head of a singly linked list. You can see in this commented list node class, I have only next. I don't have a backwards ref. It's only going forwards. So that's a singly linked list. And I'm given an optional head ref. So I need to handle the handle null head case, which is also the none head case. And so we're given a singly linked list, and then the question is this linked list a palindrome representation? Palindromes are the same forwards and backwards, so then any single digit letter or number, you can do a numerical palindrome, you can do an alphabetic palindrome, so A is a palindrome, B, and so on. Also, any collection of characters, which is a singular character, will always be a palindrome, so AAA, BBBBB, because they're all the same forwards and backwards. Does that make sense? Then you can also do words like mom and dad. They're the same forwards and backwards. I think race car is one of the longer words that's like a classic palindrome in the alphabetic palindrome collection. But here you can see in example 1, I have a representation of 1221, which is a numeric palindrome. So 1,221 is the same forwards and backwards. 101, like 101 Dalmatians. These are all palindromes, so the expected output in example 1 is going to be true. 12 is represented under example 2, and that's not a palindrome. If you take 12 and you reverse it, you get 21. So it's non-palindromic. We see some constraints. The number of nodes in this list is limited to some crazy huge number, 10 to the 5th power. So what are some potential options? So option, we can cast to a list, a set will not work here. We don't just want to know whether a character has been seen, but we need to preserve their order. So we can cast to a list which preserves order. We could not use a set. We could not use a hash map, right? Because the order of the keys is not guaranteed. We could use a list, and that would take O of n space, because I would need a list of the whole representation 1, 2, 2, 1, and then I could take that list and reverse it, and if they are equal, if they're the same list after flipping it, then I would return true in that case. That is the reason that this is considered to be an easy problem, because many early career programmers will just cast to a list, and that does the job just fine. The time complexity is also O of n, because I need to scan through every node in my list in order to save it into every node in my linked list in order to save it to my standard array, my standard list. But can I avoid this space? And the answer is yes. So what about option O1 space, just pointers? And so how might I just use pointers here? In the previous linked list problem to detect the cycle, we used fast and slow pointers. So if we continue that fast pointer all the way down to the end of the list, where does the slow pointer end up? Well, it ends up in the middle. Does that give me any advantage in this situation? The answer is yes. From that middle, if I could somehow traverse both ways from the middle, I would see the same value at every step. So consider the word mom. In the middle would be the letter O. If I had a pointer that checked O and then it went both ways out, and it could say M and M are the same. So this is a palindrome. And it works in the even and the odd case. This is going to be something you're going to consider in the palindrome. What about the even 1, 2, 2, 1? There's an even number of characters. And then mom, there's an odd number of characters. So in the odd case, it's pretty easy. I can start from O. But what about the even case? That one's less obvious. Where would the slow pointer be in 1221? Well, we can step through. So my fast, so they're both initialized to 1. My fast would go up to the 2. My slow would go up to the left 2. Then my fast would go up to the none and exit an iterating condition. And I have an option to do whatever I want with that left. I could do one more time and end up on the right 2, or I could just let it be there on the left 2. And the question becomes, what do I do from here? Well, there's an answer, which is if I stick with the left 2, I can take the next node and flip that linked list. So I can reverse the second half of the linked list, which doesn't cost any memory. It just costs some performance cycles. And if I flip that, then I'm going to have 1, 2. Well, does that help me? So I went 1, 2, 1, 2. It does help me because I can initialize a third pointer back on the original 1. And now I'm moving 1, 2, 1, 2. And I can handle the even case by flipping the second half and having a third pointer back on the head. Does this make sense? So that's what we're going to do. And that implementation is actually like a hard level implementation. So even though this problem says easy, it actually has a hard and an easy solution. We're going to go for the hard solution. So just pointers, we will fast and slow. Slow finds left midpoint. And I think I explained what the left midpoint is. It's the midpoint on an odd case, and it's the left of the middle on the even case. Slow feeds into a linked list reverse, a third pointer initialized at head, iterate through and compare third to reversed slow. Okay, so this is the more complicated algorithm that we're going to go for. So let's start that. So we're going to start with fast. Fast is head, slow is head. By the way, if not fast, so we're handling that edge case. If there's no fast at all, do we want to consider a null reference to be palindromic? I'm not sure. In a real interview situation, I think as the candidate, I could propose. I could say I'm going to consider a null to be palindromic because nothing is the same forward and backwards. And the interviewer might go, sounds good to me. Or the interviewer might say, let's consider it false. Fine, we're just flipping a Boolean, it's really easy. So I'm going to return true, but I'll say to do, if test case fails, just flip the value. It's a sign of a senior candidate when you can anticipate the failure mode, the actual or potential failure modes. So even if my test cases pass, I would be prepared to proactively debug and resolve if an edge case did occur. And that would just depend on the test set. Often in the interview, if it's an online assessment, you'll have an automatic grading. So you can get the feedback and adjust. But if it's not an online assessment, if you're dealing with a human interviewer, they'll often just say, sounds good, and you can basically proceed. Or you can write your own test case. Okay, so here I'll say while fast equals next, or fast.next, and fast.next.next, while slow equals slow.next. And I'll just let that run through to the end, and now slow is left midpoint. So I will say reversed head is, we're going to make this reverse linked list helper, and I'm going to pass in slow, and then I'll say to do, should it be slow.next? I might want to pass in slow.next, so we'll see. Either I pass in slow literally or I pass in slow.next, and I end up with the last node, this one over here, but it's all going to be flipped. I'm going to reverse the direction of next so that this is going to be the reverse head. And then I will have third head, which is just another reference to head. This is the third pointer. In fact, I could use head literally, but for readability, I'm going to pull out third head. I think readability, so this is like a nice to have, this is a minor detail, but in an interview, naming your variables well can look good for you. And even if it doesn't look good for you to the interviewer, it might just help you keep your own head on straight. So technically I could use head in place, but I'm going to add one more pointer. It's just constant memory, it's really cheap, and that's going to help me keep my own head on straight. So here I want to say while rev head and third head, if they're equal, if their values are equal, not if their references are equal. So I have a value in these nodes. Could be a palindrome. Keep checking. Else, return false. Diff values, not a palindrome. And so in contrast to the case of 1221, consider the case 1222 or 1223. These would be cases that I would expect to catch here. So I'll just put that EG there. In an interview situation, you might want to break that out as another test case for your verification step. And we can simplify this expression, can't we? But we'll circle back. So we'll circle back. This is an optimization where I could basically flip this and eliminate the else case. But I'll leave it like this because I think it's intuitive the way I've been explaining it. Now what if I get all the way through my while loop? At this point, either rev head or third head or both have become null. And in that case, we can just return true. In the even case, they should both be null. But in the odd case, one of them can be null and the other is not. And that's fine. It basically gets a free pass because that will be referring to whatever the odd node is. In the case of mom, you have the extra O there. So it kind of gets a free pass. Does that make sense? Okay. And now I need to implement the reverse linked list method. And so this will be a helper method. It's a different method. In Python, you always put self on a method that's on a class because Leetcode has us implementing a solution class. It's just the way Leetcode problems go. Lee, welcome Lee. Lee says, since the singly linked list, any means of backing up would require O(n) pointers or stack frames. Doesn't seem like O1 space unless I misunderstood you when you started working out from the middle or walking back. Third head feels like a Cerberus reference. It's non-obvious that it's a first half forward iterator. First half iteration index could be better. Yeah, I hear you on that. Yeah, okay, so let's change the variable name here. First half iterator. I'll go for first half iterator instead of first half iterator index just because it's not an integer. That's the only reason I'm going to leave off that index bit. Thanks, Lee. Good to see you. Everyone, if you are, well, I think he might be the only one on LinkedIn, so I don't know if the other channels are able to see him. McKeeman. Feel free to Google Lee McKeeman, and I hope I'm saying your name right. Very, very smart guy. And shout out to Taro, where I believe we met, if I'm not mistaken. So I'll call this the first half iterator. Let me make sure I got my variable names updated here. Okay, let's continue with this reverse linked list method. So we add self just because it's a class method, and then the only argument that I'm passing in here is going to be a old head. An old head. Hopefully that makes sense. Yeah, I guess a lot of people would have called this maybe prev. That's fine too. Make sure you and your interviewer are on the same page with this stuff, and as long as it makes sense to you, you should be good to go. So I have the old head. And what I want to do is I want to continue until I hit a none, and then I want to store a reference to the node just before the end. So I'm going to call this prev, and then we'll eventually return prev. So we're returning the 1 here in example 1. And when we return up, it's going to be the head of the reversed second half. And again, and maybe rev head second half is clearer. So we'll call it rev head second half. Okay? Feedback welcome, but I think this makes sense to me. And so while I have old head, then I'm going to have this guy just propagate down his child references. The gendering of nodes is so weird, right? Does it make sense what I mean when I say his child references? Old head.next and so on. That's what I'm referring to. So old head equals old head.next. And then priv, let's actually do this one first. So priv is going to equal to old head. So we're just storing whoever was last. It's just storing a reference to whatever we just got done checking. So that when this while loop breaks, prev will still have a reference to the node before none. Okay, so I think this is what I intended to do. Let's see how this works. Expected an indented if block. Oh, well, the curse of Python is the spacing, isn't it? Right, so here I could say pass. The better thing to do would be to collapse these blocks. I'll save that until we get done. This is taking too long. I might have something bad going on. Yeah, time limit exceeded. So somewhere we broke. So let's walk through a test case. Let's go with this 1221. Okay, so we walk in with 1221. Fast and slow are both initialized to the one node. So we should pass this check because I have a one node. So while I have the one node, fast is fast.next and fast.next.next. I think this is our problem source. So this will point to 2, and eventually it will point to none. No, I think we passed this. Let me print, and we can verify that I arrive here. I'll print fast and slow. So I'll say fast, and then I'll print slow. What I'm expecting to see is that fast is none and slow is non-null at this step. Can only concatenate string, not a none type. So fast, let me turn this into an F string. And I might need to do like fast or the literal string none, something like that to cast it to a string. We'll see. We'll see if it lets me do this. Okay, so it's going to time out again. Hopefully we get to see the print statements. I'm actually not sure if Leetcode is going to let me see the print statements when it times out. Okay, so what I can do is I can comment all this stuff. Yeah, so fast is none, that's what I expect, and then list is the value of 2 with a next value of 1. So it's the right, it is the right middle. All right, and you can see where my expectation was broken. So I thought that slow would be the left midpoint. It's actually the right midpoint. So slow is the right midpoint. Since it is the right midpoint, I don't think that I should pass slow.next. I think passing slow is good. So this will be that right hand 2. Let's see if this solves it. I think that was not enough to solve it, but let's see. So now the 2 is getting passed into this reversal. Okay, and so the question now is, where is the time limit being exceeded? Is it this while loop or is it this reversal logic? Here, I'll just do a process of elimination to debug. So I'm going to comment the line 37. And so this, if it times out again, will tell me that something is wrong in my reversal logic. Oh, yeah, and definitely something is wrong here. I never flipped the direction. Yeah, that's what's wrong. So I'll just confirm this. It should time out again. Oh, it didn't time out. So if it didn't time out, then the timeout is occurring in my while loop. I think the root cause is still coming from here. So let me fix the stitching on the direction that I think is the problem, and we'll see if I can pass at that point. Or maybe I had 2 bugs, right? It's possible that this was messed up and the while loop is messed up. Could be the case. So how do I actually flip this arrow? The way that I do this, so previous is none. While I have an old head dot next is previous. Okay. Now previous will point to old head. And I need a temporary variable. So there's an issue here. If old head dot next is previous, and then old head is old head dot next, I get a pointer back to where I came from, and I implement an infinite loop. Do you see the issue? So I need a temp variable here. And you'll often see this called temp or TMP. I also like to call it portal, because it's like you're teleporting out of this infinite loop that you would otherwise implement. And so this will be oldHead.next before I reassign it. So when I'm at the 2, portal is the 1. Then I'm going to reverse the arrow on 2 to point back to the to point back to this none. And I'm going to, instead of continuing along that line, I'm going to just jump out. So oldHead is not oldHead.next, it is portal. Portal is often called temp. So let's double check if this is right. So I cache the reference to where I want to go. Then I reverse the direction on next. And I cache a reference to the old one before I leave where I'm at. And then I leave where I'm at. I think this is correct. Now, whether this solves the loop, we'll have to see. Okay. So here, I believe RevHead second half should have a reference to the 1 node at this point. So let's verify this. And if this is the case, then I reverse the linked list successfully and my while loop is just malformed. Okay. And we have that reference to the 1. And notice that 1.next is the 2. So we successfully reversed the linked list. Does that make sense? We successfully reversed the linked list. There's simply a problem in our comparison logic. Now I know that it's true that I'm checking whether it's a palindrome, and if I get to an exit condition, it is a palindrome. And if I invalidate the condition, I properly return false. So the issue is either line 34 or line 35. Does that make sense? We've triangulated the potential root cause area to lines 34 or line 35. So let's think about this for a minute. So while I have RevHead second half, and this is going to be 1, there is an interesting thing I could do where if they're moving both in, if they ever actually touch the same node, that could be an exit condition. I don't think I usually do that, but it's worth noting. Could exit if they point at same node. Otherwise, what if they just go past each other? I think that's what I usually do, actually. So 1, 2, they're the same, and then when they cross, they're actually still the same. And they eventually hit none. So there's a like a linear speed up there, but they're both going to be O of n. Oh, Lee has another comment. Lee says, I now see that reverse second half is done via mutating. I don't Leetcode enough to consider that, but understanding now that reusing the input memory does avoid new working memory use just feels scary and gross. Yeah. But I know that's how competitive and Leetcode goes. Exactly. It is scary and gross. I agree with you. I kind of like to do it because it gets us in the practice of reversing the linked list, which is one of these classic Leetcode tricks that you would really not want to do on the job, right? Yeah, so we're able to maintain the constant memory usage if I can fix this bug. If I can fix this bug. So I'm also tempted to go ahead and simplify the condition as I said I would later. I'm tempted to do that, but I don't want to get off track because that wouldn't overcome the issue that we're seeing actually. Actually, it might. It might. So if they're ever different, return false. Oh, I'm not navigating forward. Okay, so here's the issue with my while loop. I never reassign them to the next iteration. Are y'all seeing that? So they're not actually traversing up as I thought they would. They're just referring to 1 and 1 over and over and over forever. That's the reason we have a timeout. Okay, so I just need them to traverse up. Yeah, okay. So that solves the problem, I think. Lee says, if you're mutating the list anyway, terminating the first half's last node with null would give you 2 equal length lists to compare. That's true. That's true. I could track the length. I don't need to, but that's an option, right? So there are multiple ways to solve this problem, and frankly, there's multiple ways to solve a lot of Leetcode problems. So I'll be doing it this way. This option that I pointed out, I actually don't need that, but that would also work. So there's at least like 3 ways that we've seen to do this, right? Now that I've gotten this far, we want to ask the question, is there any possible further memory improvement? The answer is no. This is constant time. You could improve it by 1 pointer if you want to use head in place. I don't think this is worth it. I like for readability reasons, I like to pull it out, and I'll pay that. It's not going to improve the complexity. And then from the performance point of view, the same answer is true. We cannot change the order asymptotically from O of n to anything else. This is the optimal runtime, but we could exit if they point to the same node, right? We could do that. I'm not going to do that, but it's another option that you could have in mind. What I definitely will do is collapse these conditions to simplify the logic. I think that improves readability, and it costs nothing from a space or performance standpoint. So instead of having the equality check, I'll have a difference check. And I can just collapse the if-else into a single if. No loss of generality, equivalent performance, and strictly simpler code. Fewer lines of code, fewer logical branches. Okay, thanks so much for being here, y'all. If you found this interesting, I hope you'll tap the like button and follow around next time. Again, this was Palindrome linked list, item 5. In the kata that I frequently practice, this is just a set of 12 problems, which I think covers the typical patterns that you'll see in a Leetcode interview nicely, covers the majority of the patterns that you'll be expected to interview on, and only 12 problems in contrast to something like the blind 75, which is 75 problems, or even the neat code 150, which is 150 problems. Great problem sets to progress onto later, but I think this is a simpler starting point. So I hope this was interesting.